Welcome my viewers and subscribers. How you all doing? I hope everything is good with all of you. Now in today's video, I am going to introduce to you engineering project management. Now engineering project management is a system that you should incorporate if you're doing medium to large scale construction. If you're doing a little 1 or 2 bedroom, you do not have to take these measures into consideration. But if you're going to build a good 2-story building, our building consists of up of 3,500 to 4,000 square feet, you need to have these measures implemented so as to reduce costs on your construction project. Now, to reduce costs on your construction project, the best way how to do that is to have proper management. Proper management in terms of your quality assurance and your quality control to ensure that the construction procedures and the material that are used to construct your building meets the necessary standard. Another aspect of that is to properly have your project quantified so you know how much quantity or how much material is going to take to accomplish a certain task. Fourth, you must have your project properly scheduled. And what I mean by having your project properly scheduled is that you know the duration of your project, because it is often said that time is money. So the longer your project is being drawn out, the more money your project is going to take. So having your project properly scheduled and you know the duration for each activity and you follow that activity's duration to the T and have your projects completed within the specified time can save you a lot of money. So in this video, I'm going to shed some light on that and show you how you can calculate the duration of your project to know when your project should end in terms of when you have started. So stay tuned for this video. In this segment of my presentation, I am going to introduce to you or demonstrate to you how to calculate the critical path for this project. So there are a few terms that you must be familiar with in order to follow me in this video. So this video, as you can see, there is a chart here, this chart. So the first column of this chart is the activity column, and the second column is the predecessor column, and our third column is the duration column, and duration is in days. Now you will observe that the first activity is activity A, then we have activity B, activity C, activity D, activity E, activity F, and activity G. Okay? Now activity A in terms of our construction for this project, activity A is clearing sites and setting out of our building. Activity B is foundation excavation and placing steel reinforcement. Activity C is pouring the footing or pouring the concrete for your foundation footing and doing your block work. Activity D is rough cast and rendering. Activity E is placing roof and tiling floor. Activity F is painting and finishing, and activity G is turning over the building to the owner. After the building has been finished, everything is done and the owner is satisfied, you can now turn over the building to the owner. So let me go back and tell you what is going on with this chart here. So we have activity A which is clearing sites and setting out of building, and that has a duration of 5 days. That means to clear the site and to set up the building, you have 5 days to do that. Activity B, which is foundation excavating and placing reinforcement, has a duration of 8 days. Activity C has a duration of 6 days. Activity D has a duration of 9 days. And activity E has a duration of 8 days. Activity F has a duration of 6 days. And activity G has a duration of only 1 day. So that information is critical because you have to know the duration of each activity. Now, to follow this chart in a more detailed way, now we have activity and we have predecessors. So there are a couple of ways how you can interpret this bit of information. Now, if you notice that activity A has no predecessor, activity B has its predecessor as A. That means activity B precedes A. That means A comes before B and B comes out of A. We have activity C which comes out of A, or activity A precedes C or come before C. So there's two ways. So you can look at it. My way how to look at it is much easier because you have to interpret this in order to know how to plot the diagram. So activity B comes out of activity A. That means activity A must be completed before activity B is started. Activity C comes out of activity A. That means activity A has to be completed before activity C is started. Activity D comes out of activity B. That means activity B must be completed before activity D is started. Activity E comes out of activity B and C. That means activity B and C must be completed before activity E started. Activity F comes out of activity C. That means activity C must be completed before activity F is started. And activity G comes out of activity D, E, and F. That means activity D, E, F must be completed before activity G is started. So if you do not understand this, I'm going to, in other videos to come, do more examples so that you can get a better understanding. So having said that, having go over the different activity, which activity precedes which activity, I have given you what the activity represent, activity A, B, C, D, through to E. I have gone through what they represent. So now I'm going to take you through the logic diagram, which we call the activity on the node, and we are going to calculate the maximum amount of time this project takes, and we're going to calculate the critical part of this project. Now, the critical part on this project, whatever activity is on that critical part, as it said, as it suggests, critical, those activity must be completed within the set duration for this project to be completed on time. Before I get into the actual plotting of the critical part diagram, there are a few terms that I want you to get familiar with before I really get into plotting this diagram. So we have ES, and ES stands for your early start. We have EF, and EF stands for your early finish. And LS stands for your late start, and LF stands for your late finish. So we have early start, early finish, late start, late finish. So how this process works, if you start early, you will finish early, right? And if you start late, you're going to finish late. So early start is equivalent or equal to early finish, and late start is equal to or equivalent to late finish. So if you start early, you finish early. If you start late, you finish late. Okay? So bear with me. So this is the diagram here, and as you can see, we have our early start, our early finish, our late start, and our late finish, and we have activity A, which has a duration of 5 days. We have our activity B, which has a duration of 8 days. Our activity C, which has a duration of 6 days. Our activity D, which has a duration of 9 days. Activity E, which has a duration of 8 days. And activity F, which has a duration of 6 days, and activity G has a duration of 1 day. Now, I'm going to plot this diagram now, so please pay attention. So, if you notice that activity A has no predecessor, that means no activity comes before activity A. Right? And this is activity A. Activity B comes from out of activity A. Right? Activity B comes from out of activity A. So what we're going to do now, we're going to merge activity A with B like this. Right? Activity C comes out of activity A also. So we're going to merge activity A with activity C. Right? Activity D comes from out of activity B. Right? So activity D comes from out of activity B. So we're going to merge activity B with D like that. Right? So we got an activity A, to B, C, D. Now, activity E comes from out of activity B and C. So we have activity E right here. So it comes before activity B and C. So we're going to link B and C to activity E. Right? So activity F comes from out of activity C. So we'll link activity F to activity C right there. Right? And then we have activity G comes from out of activity D, E, and F. So we have D, E, and F. So we have G comes out of D, E, and F. So we're going to link D, E, and F to activity G. So that is our diagram here. Now we're going to calculate our duration and our critical path. So we're going to first do what is called the forward pass, and after we have completed the forward pass, we are going to do the backward pass. But bear in mind, when you're doing the forward pass, you add activity duration. And when you're doing the backward pass, you subtract your activity duration. So just pay attention here. So if you notice, our early start is going to be 0 for activity A. So activity A has a duration of 5 days. So it's going to start 0 at 0. So we're going to have an early finish of 5 days. Right? So we have activity B and C that comes from out of activity A. So we have to carry this 5 days. So this 5 days early finish of activity A is going to be the early start for activity B and early start for activity C. You see that? So now activity B has a duration of 8 days. So we're going to add this 8 to this 5. So our early finish for activity B is going to be 13 days. Right? We are going to do the same thing. Activity C has a duration of 6 days. So we're going to add this 6 to this 5. So activity C is going to have a early finish of 11 days. Right? Now, activity D comes from out of activity B. So activity B has a early finish of 13 days. So it's going to be the early start of D, which is 13 days. And then activity D has a duration of 9 days. So it's going to be 9 plus 13, which is going to be 22. So we have 22 days here for the early finish for activity D. So we move to activity E. So activity E comes out of activity B and activity C. But activity B and C has a early finish of 13 days and 11 days respectively. So we are going to go with the higher, which is 13 days, right? Because it's going to take 13 days for activity B and activity C to complete, even though activity C has a duration of 11 days, right? So this 13, which this 13, which is going to be the early finish for activity B and C, is going to be the early start for activity E. So we're going to put our 13 right there, right? So activity E has a duration of 8 days. So we're going to add this 8 to the 13 and bring the early finish to 21. So activity E is going to have an early finish of 21 days. Now we come to activity F. Now activity F comes out of activity C, and activity C has an early finish of 11 days. So it's going to be 11 days for the early start for activity F. So we're going to bring 11 days right here. Activity F has a duration of 6 days. So it's going to be 11 plus 6, which is 17 days for the early finish for activity F. Right? So we reach now activity G. Now we know that activity D, E, and F, right? G comes out of activity D, G, and F. So we're going to go with the higher of these three activities. So activity D has a early finish of 22 days. Activity E has a early finish of 21 days. And activity F has an early finish of 17 days. So we are going to go with the higher, which is 22 days out of those three activities. So the early start for activity G is going to be 22 days. Now activity G has a duration of only 1 day. So it's going to be 22 plus 1, which is 23. So right there, we can tell that this project, barring no obstruction, no rain, no amount of days lost by rainfall or accident, pending everything goes well, this project has a duration of 23 days. But we're going to verify that by doing the backward pass. So remember now, we add our duration when we are doing the forward pass, as I've mentioned earlier, and when we are doing our backward pass, we are going to subtract. So the early finish for G, right, is going to be the late finish. So the late finish for activity G is going to be 23 days, right? Now, activity G has a duration of 1 day, so we are doing the backward pass now. So we're going to subtract 1 from 23, which is 22. So it has activity G as a late start of 22 days. Now, activity G, remember now G comes out of activity D, E, and F. So it has a late start of 22 days. So the late start of 22 days is going to be the late finish for activity D, E, and F. So this 22 is going to be 22 days for the for activity D, for the late start. 22 days again for the activity, for the late start for activity E, and 22 days again for the late finish for activity F, right? But now we know that activity D has a duration of 9 days, right? So if we should subtract 9 from 22, we are going to end up with 13, right? And for the late start here, we're going to subtract 8 from 22, which is 14, right? 14, right? And then we're going to subtract 6 from 22, which is going to end up be 14, right? So activity D has a late start of 13 days. Activity E has a late start of 14 days. And activity F has a late start of 14 days. Now, we know that activity B, D comes from out of activity B. So the late start for activity D is going to be the late start for activity B. So we're going to carry this 13 here for the late finish for activity B. And we're going to subtract 8 from 13, which is going to be 5. So the late start is going to be 5 for activity B. Now activity C, we know that activity C comes from activity F, right? So the activity F has a late finish of 14 days. So it's going to be the early finish of activity F of 14 days. So we are going to subtract this 14 day, this duration here, right, of 6 days from our activity, we're going to subtract this 6 days from the late finish of our activity. So this late start is going to equal to 8, because 6 from 8 is 14. Now we know that activity B and C comes out of activity A, or B and C comes from activity A, right? So we go with the lowest. So we know that C has a late start of 8 days and B has a late start of 5 days. So we are going to go with the lower. So we're going to carry this 5 is going to come to our A right here. And then we're going to subtract 5 from 5, which is 0. Right? So now that we have gone through the forward pass and the backward pass, we can now calculate the critical path, right? So the duration of this project is 23 days. So the critical path is always the longest part in your diagram, okay? Or the critical path is where you have your activity with 0 flow. That means you do not have any days to linger with this project. So how do you calculate the float? The float really is how you calculate the float. The float is really the late start minus the early start. right? Or the late finish minus the early finish. So that's how you calculate your float. Your float is your late start minus your early start, or your late finish minus your early finish, right? So we're going to see which of these activity is on the critical path. So if we should add up all these here, we can see that part A, activity A, activity B, and activity D, and activity G is on our critical path. And I'm going to show you how I arrive at that. So activity A, B, going back down to G is our critical path. And how do we know that activity A, B, D, and G is on our critical path? Because it is the part that we have zero float. So if you look at this, 0 from 0 is 0, right? Your late start minus your early finish is 0. Okay? 5 from 5 is 0, right? Your late finish minus your early finish is 0. So that is 0 right there. You come to activity B, 5 from 5 is 0. 13 from 13 is 0, right? You come to activity D, 13 from 13 is 0. 22 from 22 is 0, right? You come to activity G, 22 from 22 is 0, and 23 from 23 is 0. So all these here have 0 float. Yeah, so that means you can't linger with activity A, activity B, activity D, activity G if you want your project to finish on time. So let us check out the remaining activity and let's see what the floats are. So we come to activity C. So if you notice, 5 from 8 is 3. And you're supposed to get the same thing. 11 from 14 is 3. So activity C has a float of 3 days. Right? That means activity C, you can allow, when you finish activity C, you can allow activity C to remain for another 3 days before you begin the next activity. Let's go to activity E. Activity E, we have 13 from 14, which is 1, right? And 21 from 22, which is 1, the same thing. So we have activity E as a float of 1 day. One day, right? We go to activity. We go to activity F, right? And activity F, you still have a float, so 11 from 14 is really 3, right? So you notice activity C, activity E, and activity F all have floating days. So they can float, they can remain for these amount of days before the next activity starts. But activity A, B, D, and G is on our critical path. So those activities must complete within the specified duration for this project to finish in 23 days. So we have activity A, B, D, and G. So let's see what that A, B, D, and G. So we have activity A, B, D, and G, right? Activity A, B, D, and G. That means clearing of site and setting out of building, right? Foundation excavation and placing reinforcement, rough cast and rendering, and turn over the building to owner is on the critical path. So in order to finish this project on time without any lag, you must complete activity A, B, D, and G. Activity A, B, D, and G as your critical path. So activity A, B, D, and G is on your critical path. So you must complete those activities before you can finish the project on time. It must be finished on time for the project to finish within the scheduled time. That is it for this video. This video might have been a long one, but I'm going to work out more examples to get you more familiar with scheduling as it relates to engineering project management. So for my regular viewers and subscribers, you know what to do already. If you're new to this channel, remember to hit the like button and remember to subscribe. Catch you in another video. Respect and thanks.